Friends, I'm on page 163, 164. Let's see how we do. So a reminder, we do have a test coming up. On the test, yes, you can use a full sheet of paper, so make sure you're doing that. It's next week. So next week. So I don't know why I told you early. Seems to make you worry about it. All right. So let's just kind of run through these, make sure we feel good. Use the scatter plot below to do each. So we have this scatter plot that looks something like this. Okay. They want to know what would happen to our correlation if we went out to 2500 comma 0. So 2500 comma 0 would more than likely 2500 comma 0, 2500, yeah. This would move closer to -1. Is -1 good? Yeah, I mean, these are our values, okay, the correlation. Okay, so then we also have what would happen if we were at 500 comma 5. What would that red dot do? Yeah, that's going to kind of make our line of best fit do this. And so this is going to move closer to 0 away from -1. Okay? And then if I had 2500 comma 15, that kind of does that. So that's going to move that. So this is going to move away from -1. Okay? It's going to start moving it towards the 0 direction. Okay? So one dot made it stronger probably to -1, moved closer, the blue. Both the red and the purple dots and lines would have then gotten us away from the -1, which a -1 just means our slope is negative, which is good. It's fine. Is there one observation located at roughly 20? There is one location at roughly 250 comma 19. If we were to move this point, so basically there's one point that's like here. If we were to remove this point, so gone, it appears that it's slightly out of it. So it's gonna, if this was gone, this would increase our strength. Okay, meaning again, it's going to move it closer to -1. Okay, so there's just definitely some outliers there. All right, here we go. So we're going to jump on the Desmos. If that's okay with y'all. Who's y'all? That's all of y'all. All right, let's take a look at Desmos. We want the data, type this cost of a refrigerator and the lifespan of the refrigerator. Okay. No, I don't want YouTube. I want Desmos. Graphing calculator. Let's bring that down. Plus table. All right, so I have 765, enter. 845, enter. 680, 575. 809, 799, 1150, 890, 740, and 675. Okay, go back up. So this is 13.5 years. That's a good lasting fridge. 14 years, 12.5 years. 9.5 years, 13 years, 12.5 years, 15.5, last year. Ooh, 4.5, that's ugly. 11 and 10.5. Okay, so we kind of have to go find this. So I'm gonna zoom out many times, get into there's our data. Let's zoom in on that. All right. So looking at the data as it sits, we can say a number of things about the data. It's relatively flat. The reason why it's relatively flat is because my y direction is not varying very much. Okay, so we want to figure out our R value, and the way we find out R value on this, we're going to do y sub 1 tilde mx sub 1 plus b, and it looks like we have an R value of about 0.308. So there's moderate linear relationship between the lifespan. I mean, 30% is pretty weak, right? But it looks like our line of best fit fits really well to it. So what tool should we also employ here to verify that this seems pretty good or not? Even though we have such a low R value, we could take a look at our residuals, and our residual plot are the red dots. So that kind of verifies this a little bit. That's kind of nice. So our correlation on number 4 is 0.308. What data point appears to be an outlier? And it's kind of hard to see an outlier with our data that's up there. So looking just back at our table, what seems to be an outlier for you in the y direction? What seems to be an outlier? Yeah, 4.5 is definitely an outlier. So if we were to remove that piece of data, if I were to remove this, if I remove that, that one outlier changes our correlation from 0.308 to 0.87. Okay? So that dramatically changes. You changed from a 31% to an 87.3%. That's drastic. Okay? But it could be something where you might want to investigate why that one refrigerator was only 4.5. Was the data misrepresented? I don't know. If that singleton outlier was there, I would say if you left it in, be honest if you removed something, but if you left it in, I would definitely say you would probably want to collect more prices and lifespans of the refrigerators in this case, and then that outlier is going to not mean as much. So if you have an outlier and this was all of your data, be honest when you're printing your reports to say, hey, I eliminated this outlier because, and this is what it showed with the majority of the rest of my stuff. Okay. What are you guys? Pecker, you made it, yes. Laura made it. All right. All right, then after that, so outlier should be investigated. Number 8, assume that the flood damage, the outlier refrigerator. So if you found out, so they're saying, hey, let's say that there was flood damage that happened on that warehouse that refrigerator's in. That's why that refrigerator went down to 4.5. List that. That's something that hey, due to flood damage, this refrigerator is substantially less. So I'm going to remove that outlier because the refrigerator had flood damage. Okay. And then let's see. It's kind of hard to read. So number 9, what state would you think was an outlier in 79? You could probably say West Virginia. You might be able to say, I think that's Minnesota. And then Alaska, 8K. And then which states would you identify as possible outliers from 2012? I'd say it looks like Wyoming, Alaska. That one that's at the very bottom, I think it says NE. That looks like maybe Nebraska. That might be. And then the strength association increased substantially between 79 and 2012. Do the outliers explain this change? Being that the outliers are for the most part the same, especially the Alaska and West Virginia and Alaska and Wyoming, the outliers kind of would have changed it a little bit, but there's only 2 outliers. They're not dramatically so far out. So those are a few things. All right, so 211 notes or someplace that Stirrup don't know. So again, we have a test, I believe, on Tuesday. So again, full sheet of paper, front and back, okay? Let's take a look at 211. 211 starts talking about, I'm on page 59. Page 59 of the notes. These are influential points. So we've seen outliers are unusual observations, and they impact the correlation. And then some outliers also alter the position of the regression line. And the outliers that move the position of the regression line are called influential points. Okay? So if you had an outlier like this, if this was your data, and you had an outlier right here, that's not necessarily going to change what our line is going to look like. It's the outlier that's up here or the outlier that's down here. The red and blue, those are going to be your influential points. Influential points. Okay, the green is not because it falls pretty much in the line of best fit. If you're looking at the information, so our original line of best fit would look like this with the green. But if I had the red, that's going to change that. If I had the purple, that's going to change it this way. So our line of best fit changes a lot. Okay, so that's going to change our responses. Okay, oh, thank you very little. Oh, she's not here today. No, sorry about that. No, she's not. Outliers are supposed to be investigated. If there's good cause to remove them from the data, do so. So like in the homework, it said we had these refrigerators, all this cost, and this one refrigerator only lasted for 4.5 years. The reason that refrigerator only lasted for 4.5 years is it was in a hurricane. It was flooded. So that kind of messed it up. Okay, so there could be times that you come across data that you know that particular data has had something from the outside source that has impacted it dramatically. So get rid of it. But you put in your report, I eliminated this outlier, and this is why I eliminated the outlier. I had significant impacts from an outside situation that took away from it. So what does statistician do? In the case above, very reasonable conclusion is to use regression line to make the predictions, but note the model is unreliable for the kinds of values of the explanatory value that produce the outlier. As you can see, the outlier possesses an unusually high value of x, the explanatory variable. Perhaps the model breaks down at such values. So that's just, I can't really read. It's just showing you influential points. In fact, influential points are almost always outliers of the x variable. For that reason, they pertain to the underlying mathematics creating regression equations. Outliers in the y variables are likely to influence the position of the line itself. Okay, on page 60, it's a very similar diagram to what I have. They call this point C, they call this point B, and they call this point A. So points A, B, and C are outliers. All of them don't fit in the general form of the scatter plot. Point A is an influential point because the explanatory variable outlier does not fit the general trend. So in the x direction, A is being impacted. Point B could be an influential point, but it's not, although it's an outlier in the x variable. The point lies on the same linear path as the rest of the data. The effect the point B will be to increase the correlation closer to 1, so positive slope, increasing association between the variables, but the regression line will not move. Point C is another outlier, but is not. Point C is an outlier, but it's not an influential point. This point will decrease the correlation, so this will lower the R value because of the strength of the association between the variables, but probably not have a significant effect on the regression line. A slight increase in the slope of the regression is possible. Okay, so there are just some definitely things that are taking place. So when you're looking at outliers, is it affecting more of the y or is it affecting more of the x? So A is affecting the x. This is affecting the x direction. This is affecting the y direction. So the x direction is more of an outlier that's going to have more of an influence because the being pulled in the x direction more. The C value is happening more in the y direction, so that's definitely something to take note of. So 211 is I think we can work on page 155 or 165, 166. So page 165 and 166 are definitely there. Hey, a reminder, friends, we do have homeroom today. If you wanted to come by and take a look at your quiz and get half your points back, we can do that. Or if you owe me a quiz, you can come in and do that too, if that works for you. That's all I got for you. Sound good?